Well, if computer programs could only do one thing, just go from the top to the bottom, that wouldn't be very interesting. So we've built them so that they can do more than that. They can make decisions. We can say something like up here that I want x to become 2, and then I want to make some sort of a decision where I'm going to say, if this is true, then I'm going to do this piece of code over here. Maybe also optionally, if it is false, I'm going to do something else over here. So we can make a decision as to where it goes in the code. And then we can combine afterwards and we can go on to the next thing in the code. So this sort of a thing where we make a decision, we say x is equal to 2, or x is equal to 3 and we're deciding something else, or we make a decision, is called an if. And I've been using some of these in the code, but let's talk specifically about how they work and how you can build up more complicated things than just a single thing. Now in Python, we know that our equals up here is not an arrow. It's just a single equals. And we have, I put a double equals right there. It's not very visible, but I'm going to write up a piece of code there, and then you'll be able to see, this is a single equals, that's a double equals, this is a comparison, is the double equals. Python, conveniently enough, catches if you use a single equals inside an if and says, no, you didn't intend to do that. That was a mistake. Some other languages, not so kind to the programmers. They let you make that mistake, and sometimes you intended to do it, and sometimes you didn't. So, you start looking at, Python helps you. This is one of the ways that it does. Let's take a look at a piece of code with an if in it instead of a diagram, and be able to decipher what it does. Okay, we have a little piece of code here, and this is one of those cases where the visualizer would help us, but what's really good is we're going to go into VS Code, and it's good for this kind of stuff. Will let us walk through this and see how it works and what the values are and how it's going. So this is where you start seeing some power from using a debugger. And there are other ways you could debug code like this. This is not a big complicated piece of code. But a debugger can be a useful item. So first of all, notice that we have x is 2 up here. That is an assignment, so it takes 2. This is a single equals, right there. And down here we have equal, equal. 2 equal signs with no space in between. That's a comparison operator. And when we compare x to 2, what we get is true and false. We get little values like this, that x is equal to 2, okay? We get the two different values where x is 2, we get true, and where x is not equal to 2, we get false. So we get a set of values that are true and false out of this. That's the two sides to our little diagram. Now, if it's true, we're going to go do this side over here. And if it's false, we're going to do this side over here. Now, look at what we print out. Print x is 2, okay? Which is true. Yeah, x is going to be equal to 2, so we're expecting to get this one right here. Now, if for some reason x wasn't 2, we gave it a different value, we'd expect to see down here. X is a substitute in whatever the value is down there. But this tells you what you can do with a really simple if, else. The else portion is optional. You can just have an if. You don't have to have both sides. So you could have just said, if this is true, this is the piece of code I want to do. Maybe there is no other side to it. Okay? That's the kind of a diagram where you have something like this. And this is not that uncommon a thing also. You have some comparison, but you do this piece of code over here, but only when this value exists. So, yeah, you can have code like that as well. You can reverse the logic. You can combine pieces of logic. We're going to go through each one of those. But here's the diagram if the else doesn't exist. Now, one thing we can do in Python is, at the Python prompt, we can interactively go say things like x equals 2, and we can then turn around and say x equal 2, and it should print out a true. We can say something different, like x equal 3, and it'll print out a false. So we can actually go and try these expressions. Now, maybe we want to check for a more complicated thing, like we want to say this, where x is equal to 2 or x is equal to 4. Now, what happens when we combine these things, you notice my little or here, is we do this comparison first, okay, and then we do this comparison, and then we combine the two pieces together with an or to get a final result. So if x is 2, then x equals 2 is true, and x equals 4 is false. So we would expect that what we're going to print out here is that it's going to say that this is true. So it's important to realize that this is equivalent to saying, in this case, we can put parentheses around these. I would prefer most of the time to put parentheses and not depend on whether or not Python is evaluating it in the order you'd like to evaluate. If you have something more complicated than this, some parentheses are generally a good idea, at least for the human. Python knows what it is going to do, and it will do it, but you don't want to introduce uncertainty for the human beings. So you can combine this. Now, we could also do and I'm going to show you an example of and. Now, or and in a computer don't work the way you and I use them in English. So that's an important thing to know. I mean, when I go into a restaurant, okay, and the waitress comes up to me and says, "Would you like pie or ice cream for dessert?" She's not expecting the answer yes. She'll think that's very odd. Okay? She will expect you to pick one of the two. So in English, or is usually an exclusive or, where it's this or that, but not both. In a computer, we have a separate thing for exclusive ors. We'll eventually get to that. But for right now, the ands and ors, I'm going to show you how they work first. And then we're going to talk about, yeah, this is how you use it. So the way that ands and ors work, okay, is we're going to do and I'm going to have the input variables, A and B, and we're going to say here's the output. And I'm going to write trues and falses for these things, so we're going to do it as true, 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 false, false, true, and false, false. Now, this is and, so if one of them is false, then you'd expect the output to be false. So let's see, this one is false, therefore I know that this is false. This one is false, so I know that this is false. This one is false, so I know that this is false. There's no false there, so this is a true. Now, this is one way to write it, okay? The computer does it in terms of electrical signals. So we might want to re-diagram that in terms of signals and say 1, 1 for a high voltage is a 1, 1, 0 is a 0, 0, 1 is a 0, and 0, 0 is a 0. Because it looks at it in terms of electrical voltages. So its representation is not what we think about. It's looking at it in terms of amount of power. Now, this is one way to represent. We're going to do or next. All right, we have an or. We're going to do a truth table with A and B again, and an output. And when we do this, what we're going to do is we're going to look at the values that we have of true, 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 false again, false, true, and false, false. And with this kind of values, if both of them are true, if there is one true in any line, then it's going to be true. That's the way that the or works. So this one up here has at least one true. That's true. This one has a true, so that's true. A false, that isn't true. True, yep, that's true. And no trues at all, so this is false. So when we look at it this way, an or is not like the ketchup or mustard. You're saying, yeah, I want both. I want ketchup and mustard. So this is different than English, but this is the way the computer looks at or. So if either one of these happens, and some programs, depending on how you do it, you notice I only circled one. If I have, and I don't know which way Python works, I would find out from some experimentation, but x equals 3 or x equals 4. If x starts out equal to 3, it does this. This is true. The question is, does this ever happen? Or does it skip past that completely? Does it ever evaluate that? That would be something that if you're going to program in Python regularly, you need to know. Okay? I'll go run a test and find out. Today during lecture, and we'll figure that out. I'll show you how you figure out something like that about the language. But if it doesn't do that, and that's my suspicion that it doesn't, it just looks at this, and if this is true, it's done. This is what we call a shortcut execution. And there are languages that are shortcut execution, and there are languages that say they will evaluate all of them all the time. And there are good pros and cons to both sides. And I very rarely know for certain. If it makes a difference in my code, I will do a test to find out right then and there. But that's not something that I would remember. I would do a test and figure it out. So this is the OR, and that's how it evaluates stuff. And you can combine them in more complex ways. You could have expressions that have ands and ors. My general view of complex expressions like that is that if I've got an if and it's got this and this and this and this, there are some exceptions, but and then it does or this and this, I would not like that. I would want to rewrite that piece of code to be something that's easier for the human being to digest so that they can better understand it. And it's not the computer that's having the trouble. It's the human being's comprehension of that piece of code. Now, where we're going with this is I'm going to show you some examples on the computer, a series of examples with a tiny little function that basically does an addition or returns a constant. It has one if in it. And the function isn't the point of the exercise. The function is in the example. It's to use ifs, and one of the most common ways that you do this is to automate the testing process. You want to know, I've got a piece of code, here's the expected results that I expect to get out of this code. And did it do these things? Or did it do something else? And at the end of your test, you've got to ask the question, did I cover everything that it was supposed to do? Did I leave any cases out of the test, or was I thorough? Now, tests are not just there for the sake of you developing the code. They're also a piece of the documentation of, you've got this complicated routine that does a gimquasi, or a what's-a-doozle, and it's got 8 parameters. What are legitimate values for those 8 parameters? And the next person that comes along and looks at your code wants to see the test to say, oh, that value has to be in this range. Because when it wasn't in this range, there was a test that produced an error. And they checked to see that it produced an error. And documentation is good when you write down what it does. But a lot of times, you read the documentation as a human being and you go, and how do I call this routine? What do I do with it? How do I make it work? And then you go to the tests and you go, okay, I see some examples and now I begin to understand what the documentation meant. So tests are not just to make certain that your code works, they're also to show other people how it worked and how you tested it. And later you're building some big application, you've got a series of tests, and somebody calls in from the customer support department and says, well, this customer is doing this and it failed in this way. And you go, did I include that in the tests? And then you go look in your tests and you say, oh, I never thought of that case. Let's put in that test. Oh, it breaks just like they said it broke. Oh, we better get that fixed. And that's another thing that you use tests for very regularly. And tests, when I show you an example, you're going to see that the tests are bigger than the code. That's not an uncommon thing. Quite often the test code, you want it to be really simple. That means it grows big. If you make complicated test code, it's really hard to test the test code and make certain that the test code works. So you want simplicity in the test code, and that means it grows, not complex test code. Sometimes you're stuck with complex test code. It's horrible. Then you have to write tests for the test code. And that gives you a headache. At least gives me a headache. But most of the time you get away with, I build some stuff, I build some tests, I make certain it works. I know this piece of my project works, I move on to the next piece. And you successfully do that over and over, and you take a giant pile of stuff you need to do, and you just keep snipping out pieces of it and reducing the size of the pile, and you get down to, oh, look at that, I built a great big program. One little piece at a time with one little test. Okay, you just go around and around and you iterate on it. So that's kind of the way ands and ors work. We're going to have more examples in the examples, and there's really good examples in the book. And hopefully, this is going to make sense, and we're going to use that for automating our testing process. We're first going to do an example that I've contrived. It's kind of idiotic, but we'll see how we do automated testing. And that will show you how to do the testing, hopefully. And then we'll move from automated testing to, we'll go back to that quick sort, and we'll test the quick sort. And we'll build a series of automated tests for the quick sort to say, does it test in every way we need to? Did we leave anything out? What happens if, and we'll pass it some things you're probably not thinking about, and ask the question, what does it do when you test for these things? What does it do when you sort these things? Okay, let's go get in front of the computer and bring up VS Code and run some experiments.